Okay, we are going to solve a system of equations here by converting our augmented matrix into row echelon form. And then in this video, we're actually going to take it a little further and go all the way to what we call row reduced echelon form, which wouldn't really be necessary, but we're going to do it for fun anyways. First off, let's write out what this system of equations actually would represent. So this is really some matrix A times some vector x equals some coefficient vector, where A is all these coefficients. -5, 6, -3, 3, 4. Our x vector is, say, x, y, z. I mean, we could theoretically, we could use A, B, and C. We could use whatever variables we want. And then our constant vector here on the other side is 3, 6, 6. Okay, so what did this come from? Where did we get this? This was the system of equations. Think about multiplying this through by here, row times column. This is x minus 3y plus 4z equals 3. That's what the top row times this column equals that single number. And keep going. This is 2x minus 5y plus 6z equals 6, and -3x plus 3y plus 4z equals 6. So this is the system of equations we're actually solving. Okay, so let's convert this to row echelon form. So just for completeness, let's rewrite the matrix here. The augmented matrix. Remember, you get the augmented matrix by taking your matrix A here, all your coefficients, putting in this dashed line, and then putting the answer vector over here, the coefficient vector over here that are all constants, in a column at the end. Okay, our goal here is to get this in upper triangular form with ones along the diagonal. So our goal using row operations is to get something of the form 1, 1, 1 along the main diagonal. These will all be zeros, and we'll have numbers in here, and then we'll have numbers over here. Then we can just use back substitution, because this final line here will tell me what z equals. This final line will say z equals whatever number is there, that then we can plug in here to solve for y, that then we can plug in here to solve for x. This is called row echelon form, REF. And then, like I said, for fun, we'll get it into RREF, where all of our answers will be living right here. Okay, so we want a 1 here and zeros below it. So step 1, there are a lot of steps here. Get a 1 right here in the top. Done. Check mark. It's already done. There's already a 1 there. Step 2, get zeros below that 1. Above, I like to say above and below the 1, but in this case, we only go below because there's nothing above him. So this is the way we do each column. We get the 1 along the main diagonal, and then we go above and below that to get our zeros. Okay, so how am I going to get my zeros? We get our zeros by adding copies of that 1 to cancel out, say, that 2. So what do I wish was here? If I were going to add row 1 and row 2 together, what do I wish I had right here to cancel out the 2? I wish that was a -2. So I need -2 plus 2 to equal 0. We get our ones by dividing. We get our zeros by adding copies of rows. So I want to do -2 times the old row 1 plus the current row 2, and that's going to become the new row 2. Let me go small. Okay, so let's write that out. Here's old row 1. It was 1, -3, 4, 3. Or -3, 4, 3. Old row 2, 2, -5, 6, 6. I'm going to take twice row 1. So double everything here. That will give me 2, -6, 4, twice 4, 8, 6. I'm going to add that to the old row 2. Oh, I need these to cancel. I need -2 row 1. So I'm taking -2 times row 1. That will change all these signs. Add that to the old row 2. And the whole point here, what I'm hoping to get is a 0 right here at the beginning, which I do. And what do we get here? 1, -2, 0. Now, the fact that we got a 0 over here is just pure coincidence. In fact, that's probably going to go away at some point. Okay, so what did we get here? This is my new row 2 right here. Now, up here, this always confuses students. So I took -2 times row 1, but I just use that as a tool. I'm not changing row 1. I'm not going to change this row. I'm using a copy of it to cancel out this 2 here and get a 0. Remember, anytime you have two equations, you're allowed to add copies of them together to generate a new equation. So that's really what I did, was I added these two rows together to create a new, brand new equation. And that new equation is going to become my new row 2. So row 1 stays the same. Even though I took -2 times that, that was just a tool I used to get a 0 here. So this guy's going to stay the same. And now I've replaced this row with something that has a 0 right here. So my new matrix will have the same row 1, 1, -3, 4, 3. This is the new row 2. And then row 3, I haven't done anything with yet. Now, normally, once you get good at this, you do multiple things at once. Like if we were doing a bunch of these, we would go ahead and take care of this guy right here and make him a 0 as well. By, again, using the 1. You use the 1s to get your 0s. But for clarity, I'm going to rewrite. I'm going to write a whole bunch of steps here. -3, 3, 4, 6. Okay, so 1 stayed the same. Here's row 1. Row 3 stayed the same. Now I've got this new row 2 that has exactly what I want, a 0 there. So now let's get a 0 right here. Use the 1s to get your 0s. So what do I have to multiply 1 by to get rid of a -3? 3. So I want 3 times row 1 plus the old row 3, and this will become the new row 3. So this is the way we write it out when we're doing row operations, and we have to understand that that is old and this is new. We're replacing row 3 with this here. So let's write all that out. -3 times row 1 will be, or sorry, +3 times row 1, 3, -9, 12, 9. Old row 3, just keep him the way he is. Add those straight down. We get 0, -6, 16, 15, I think. Let me check that. So now this is my new row 3. Everybody else stays the same. I only changed one thing at a time, the new row 3. So let's rewrite the matrix now again. 1, -3, 4, 3. 0, 2, and 0. That 0 is going to disappear in a minute. And now this new row 3, 0, -6, 16, 15. Okay, next step. We want ones along the main diagonal, zeros below those. Our next step is get a 1 right here along the main diagonal. We work our way down. We get a 1, get our zeros. Get a 1, get a 0, get a 1. How do we get our 1s? By dividing through by whatever was there. We got lucky in this case. There's already a 1 there. Check. If there wasn't a 1 there, if there were a 5 there, we would divide this entire equation by 5. The 0 here, 0 divided by 5 is still 0. That wouldn't hurt anything. This is why we got to do things in a particular order. If you try to do these out of order, you're going to mess up the work you've already done. This is the order in which you do things. Make this a 1 by dividing through whatever is there. Then use that, whatever you get here, this 1, to get the zeros below it. Next, you move over to the next column. Make this a 1 by dividing. We get our 1s by dividing. Use him to get the zeros. And in this case, we're just going to get this guy a 0, but then we're going to take it further and also make him a 0. We'll do that in a minute. All right, now get zeros in the second column. So we work one column at a time. Remember, columns are up and down, rows are left and right. So I'm going to use that 1 to get rid of this -6. So what would I have to multiply 1 by to kill a -6? We want 6 times the current row 2 plus the old row 3, and that will become my new row 3. So I'm only going to write all this old new stuff a couple more times. This is the way it always works. Take some copy of that 1, wherever the 1 is, plus the guy you're trying to change, into a new version of that row you're trying to change. Okay, so 6 times row 2 will be 0, 6, -12, 0. Old row 3 is 0, -6, 16, 15. We're just going to add straight down. The whole point here was to cancel out there. What do we get? We get 0, 0, 4, 15. Let me check and make sure I have not good. That is correct. Okay, now let's rewrite the whole matrix. -3. 3. And here's my new row 3. Okay, now we get a 1. Get your 1 along the main diagonal, use that 1 to get your zeros. Get a 1 along the main diagonal, use that 1 to get your 0. Get a 1 along the main diagonal. How do we get our 1s? By dividing. So we're going to take row 3 and divide everything all the way through by 4, and that will become our new row 3. We get our 1s by dividing by whatever is there. Okay, so now my matrix becomes we're only changing one row at a time. If you try to change multiple things at a time, you're gonna have a bad time. 0, 0, dividing everybody by 4, 1, 15 over 4. Okay, we have now reached row echelon form. This is what we call upper triangular because I've got a triangle of elements here. Echelon form because these are 1s, these are all 0s. We can now solve, like we've solved the system of equations here. This, if we were to write this out, says x minus 3y plus 4z equals 3. 0x plus 1y minus 2z equals 0. And then 0x plus 0y plus z, 1z, equals 15 over 4. We could solve this just using back substitution. I've already got z. That's the whole point of doing this. I've got z now. Z's right in front of me. I can plug that in here and now get y. So that'll say y minus twice z, or I guess that'll be, 15 over 2 equals 0. So y equals 15 over 2. Now I have y. Now that I have x and y, I can plug in here to get x. So x minus, what is that? 45 over 2, 3 times this, plus, I could write that as just 15, but I want a common denominator. So 4 times 15 over 4 would be 15. I'm going to write that as 30 over 2. So that's 4 times z there. And that's supposed to equal 3. I'm going to write that as 6 over 2 so that I have a common denominator. So what is this? I think that is x minus 15 over 2. And this, sorry, that was 6 over 2. So I think x is 21 over 2. Let me check that real quick. Okay, yes, I believe that is correct. Okay, so we've solved the system. We're done. We don't have to do anything else. But just for fun, I'm going to go a little further with this. We have right now what we call row echelon form, also called, so AKA, also known as upper triangular. With ones along the main diagonal. Upward triangular just means we have a triangle here. And we could still solve that. Even if we didn't have ones here, we could still do this back substitution and solve our system, which is our ultimate goal. But I'm going to take this further and get to our REF, row reduced echelon form, by making all of these zeros, making this the identity matrix, then all of our answers will be over here. So what we have right now, our row reduced echelon or row echelon form looks like this. 3, 0. We got a 15 over 4 here. I've got a 0, 1, 1, 0. And what's that last guy? -2. Okay, so again, I'm just going to reiterate this. If we're just trying to solve the system of equations, we're done. We already have the answer. I've got X, Y, and Z. We're going to need this technique, what's coming later when we find inverses, where we have to get to row reduced echelon form. So I want to go through the extra steps of teaching that now. So now I'm going to use the ones to get zeros above and below them. And I'm missing a 0 right there. Yeah, there we go. So this one here has zeros below him. I'm happy. This one has a 0 below him, but not above him. So now I want a 0 there. So I'm going to use the ones to get my zeros. So I'm going to take 3 times row 2 plus row 1, and that will become my new row 1. So 3 times row 2. And I'm telling you, you got to write out all these steps. That's going to be 0, 3, -6, 0. Old row 1, 0, -3, 4, 3. Add those straight down. I get 0, 0. Wait, sorry. Old row 1 had a 1. I left off that 1 there. 1, negative. Here's row 1. 1, -3, 4. So I get 1, 0, -2, 3. Okay, so here is our new row 1 now. Let's put everything back in our matrix. Again, these are much easier if you recopy everything at every step. You got to be really careful, though, that you don't copy something wrong. I actually already recorded the end of this video, and I copied that right there wrong. So I went on for another few minutes only to realize at the very end that I got the wrong answer. Now I have to re-record this. So you got to be very careful is the point I'm making. Okay, so we got our 0 here. Now let's get our zeros here. And let's do both of these at the same time. You just got to be really careful. So I want, because I'm doing something similar here. I need these to be zeros. Use your ones to get your zeros. If I do 2 times row 3 plus the old row 2, that'll give me a new row 2 that has a 0 right there. So 2 times row 3, that'll be 0, 0, 2, 15 over 2. Old row 2, 0, 1, -2, 0. Add straight down. I get 0, 1, 0, which is what I want. 15 over 2. And again, without rewriting the entire matrix, I'm going to do twice row 3 plus the old row 1. Why twice again? Because I have the same number there. So I'm using this 1 to cancel out that -2 there. So this will become my new row 1. So here is my new row 2. I have to remember that. This, what I get here, will be my new row 1. Twice row 3. Old row 1. Add straight down. I get 1, 0, 0. 15 over 2 plus 3. So let's see, he would be 6 over 2. I think we get 21 over 2. So this is my new row 1. So let's squish all this together into our matrix now. What do we have? 1, 0, 0, 21 over 2. New row 2 right there above us. 5 halves, 15 halves. And row 3, 0, 0, 1, 15 fourths. Now that this is the identity matrix, ones along the main diagonal, zeros everywhere else, here's my solution. This says x equals 21 over 2, y is 15 over 2, and z is 15 over 4. Again, we did not have to go this far to get the solution. Once I was in row echelon form here with ones along the main diagonal and zeros below that, I could just use back substitution. I got to do a little more arithmetic and algebra, but I can still solve for x and y by substituting back in. If we go all the way to row reduced echelon form, our answer is here. Now, 2 reasons why I want to go through all this. One, if we're using the inverse, this is the process we use to find an inverse. We get the identity matrix here in row reduced echelon form. Secondly, we've got these smart calculators that will do all this for us. I could start right at the beginning at this matrix way up here, type this into my calculator, tell it to put it in row reduced echelon form, and I'm done. Let me show you that. Before we get to the calculator, I just want to show you what this would look like if it were all typed up nice and pretty. These are literally the same steps we just went through to get row echelon form. So this was an example from your book that I'm doing. It's example 6, and it's typed up nice and neat. Probably looks a lot prettier than what I had, but they're missing a lot of the steps in here. Okay, so how are we going to do this? We're going to get to the matrix function on our calculator, which is right here. Notice these blues, so I have to hit second matrix to get in there. And I'm going to go to edit and pick some matrix that's empty. Like I could clear out a matrix, but we'll just pick one that's empty, B. I have to tell it the rank of this matrix. Remember, rank or dimensions is rows by columns. How many rows do I have? 3. Hit enter. How many columns? 4. He's a 3 by 4 matrix. That's the augmented matrix there. Now I just type across. When I hit enter, see, watch, I hit 1, enter, it automatically scrolls over. Now, don't type this. That is not how you type -3. That's the minus button. That's the negative button. If I do that, it's going to give me an error. I have to type -3. And then I can just hit enter and it'll just scroll over. 4, 3. Watch what happens. It goes back to the beginning of the next row. I just keep typing. 2, -5, 6, 6. Oh, I done goofed there. That was a 6. -3, 3, 4, and 6. Okay, now what I like to do once I get here, get out of this menu. If you start trying to do the next step while you're still in this menu, you're going to end up messing up your matrix. Quit, hit second, quit. And then if I'm really being careful, I'm going to come in here into matrix, go down to matrix B and hit enter. So it will display that on the screen, hit enter twice, and I'm going to double check that I typed everything correctly. Yeah, everything looks right. Okay, now we're going to put him in row reduced echelon form. So second matrix, and I go over to math, and I want to go all the way down to RREF right there. And it's asking, what matrix would you like to apply that to? So to grab matrix B, notice that there is a B right there, a little green B. That won't work. It has to be matrix B. I have to get it from the matrix menu. So I hit second matrix, scroll down to B, close my parentheses, hit enter, we're done. If the system of equations has a unique solution, then we will end up with the identity, the 3x3 in this case, identity right here. And these will be our solutions. That's X, Y, and Z. And that's exactly what we just got. And that took like 20 seconds. When you get into your physics class, when you get into your differential equations class, you're going to have to solve systems that are this big or bigger, and you don't have time to go through all these steps that we're doing here. This is how you do this in the real world. And that's a good place to stop.